And like you just said, I'm here to tell you about the 9 companies that are competing for the 2020 $100,000 Ray of Hope Prize. These startups show us how we can learn from nature to enable and to embrace the circular economy by tapping into life-friendly materials, chemistry, and systems. So just as a heads up, I'm going to explain these companies very quickly. I wanted to note that 7 of the 9 startups are women-led. At the end, we will announce the winner and learn more about their work. So ready for this? Let's get started. I need control of the clicker though, I think. Let's see. 1 second. Or you can advance when I say go, if that's easier. All right, well, why don't we go ahead to the first slide here. Great. And let's keep going to the next one. And one more for me. Yeah, perfect. So diving right in. So more than half of us, 4.2 billion people, live without access to clean, safe toilets. Go ahead to the next one. Change Water Labs created a toilet that mimics the process of how plants pull moisture from the soil, releasing it as water vapor through their leaves. And our poop and pee are 95% water. Their toilet evaporates water from our waste. All right, go ahead to the next one. The next company up was inspired by the carnivorous pitcher plant. They have a microtextured ridge that becomes extremely slippery when wet so that insects fall inside. Next, the company Spotless Materials created a slippery coating that emulates the same tiny structures found on the pitcher plant. Their easy to apply spray repels poop, mineral deposits, and even bacteria. Go ahead. And one more for me. This is the Manta Shrimp, and Manta Shrimp pulverize their prey with a punch that's faster than a .22 caliber bullet. And it can do this over and over again without damaging its clubs. Well, here's their secret. Layers of chitin that are each offset by about 15 degrees. And if you can go ahead to the next slide here. Helicoid Industries follows this blueprint to make stronger, more durable, and lighter composites for wind turbines and airplanes. Can you go to the next one for me? There are more than 14,000 miles of US coastline that is covered in concrete, and 60% of China's coast is covered in concrete as well. Well, eConcrete saw this as an opportunity, go ahead to the next one, and creates coastal construction that acts more like coral than concrete. Living organisms grow on it, regenerating ecosystems while strengthening the structures over time. And we can learn a lot from butterflies. Their wings have a high surface area and a very small footprint. The company Metalmark Innovations is bringing this design to catalytic converters because they can place catalysts at precise points inside of the structure. All of the catalysts get exposed to air pollution while using less materials. Can you skip ahead a few slides for me? And 2 more. Yep. We need more effective and affordable alternatives to synthetic pesticides. And if you go ahead, one solution popular with organic farmers are nematodes, which naturally attack pests. Nematodes communicate via chemical pheromones, and the company Theranim replicates those pheromones, causing beneficial nematodes to attack more pests or to even dig deeper into the soil. Alongside pesticides, we spend over $18 billion per year on fungicides to keep fruit and vegetables from spoiling. Yet 30% of those chemicals are banned. But the good news is that plants already have a natural mechanism for fighting fungal infections. If you skip ahead, we'll go to nanomic biotechnology that has encapsulated these plant defense molecules, which attach to the skin of the fruit. And as soon as the fungus starts to form, it actually triggers the release of these protective molecules. All right, let's skip ahead 2 minutes or 2 slides here. So we couldn't talk about biomimicry without talking about color. This photo shows effluent from a nearby textile dyeing plant, one of the leading causes of water pollution. The company Wearable is growing colored fibers in a lab without dye or pigment. They go out into nature and look for proteins that make color, such as the pink of the Discosoma coral. So if you go ahead a slide, we'll see that. They then grow cultures of that protein in biodegradable material, ferment it, and then spin it into fibers. And let's go to, here's the butterfly again. The wings of the Morphocypress butterfly contain millions of stacked nanostructures, which reflect blue light waves back to your eye while allowing other wavelengths to pass through. This is known as structural color. And if we go to the next slide, we can see how cypress materials created a nanostructure that self-assembles to reflect light in the same structural way. Their bio-based paints contain no dyes or pigments, and they can use the same process to reflect infrared or UV light, reducing heating and cooling loads. So we'll end here on this last slide. We are sharing these stories to show that biomimicry, the process of learning from nature, is solving real problems today. And this competition is only possible because of this man and his belief in biomimicry, Ray C. Anderson. So now let me introduce our partner, the Executive Director of the Ray C. Anderson Foundation, John Lanier.
Thank you, Jared. For 5 years now, the Ray C. Anderson Foundation has been proud to award the Ray of Hope Prize because it so perfectly captures what Ray Anderson stood for. He believed that biomimicry offered businesses just like his, Interface, a better way to do business. And Interface showed the great success that biomimicry can offer to businesses. In judging the teams competing for this year's Ray of Hope Prize, what stood out most to me is that each and every one of them has a clear path to move forward and to be successful. But here today, we're just going to be sharing 2 of the teams who will be winning prizes as a part of this competition. Winning a $25,000 second place prize is Cypress Materials. Their work in structural color will have application in products all across the board. And winning this year's $100,000 Ray of Hope Prize is E-Concrete. And the judges were so impressed by their new and novel approaches to creating marine concrete structures. And the biomimicry story they have to tell is one of the best that I've ever seen. And now to share a bit more about their work with you from the team at E-Concrete is Shimrit.
Hi, thank you so much, John. It's so exciting for us to win this year's Ray of Hope Prize. And I really want to thank the Biomimicry Institute and the Ray of Hope for giving us the honor of taking the lead in this biomimicry role and helping companies make the planet a better place. So for me, it's a real personal story. I'm a diver, and I met my co-founder, Ido Sella, 20 years ago. Ever since then, we had the opportunity to dive and explore beautiful, amazing ecosystems across over 30 countries, seeing amazing reefs and other ecosystems. But we've also witnessed devastation, reefs utterly destroyed. Coastal development is one of the main reasons for loss of coastal habitat and for loss of biodiversity. We're losing whole ecosystems for us, humans. With over 50% of the world population residing along coastlines, coastal development and coastal hardening is inevitable. About 70% of all coastal and marine structures are concrete-based. So we're seeing more and more seawalls and breakwaters that are made of concrete, paving our coastlines, making concrete the second most consumed material in the planet, second only to water. Concrete is also a most carbon-intensive industry, responsible for 8% of the entire carbon emissions of humanity. This, of course, also fuels another global problem of climate change. So now, faced with these threats, we're seeing more and more storms coming in strongly and more frequently. And we're also experiencing accelerated sea level rise. All of these, of course, have left us with no choice but to use concrete structures for protecting our shorelines and our coastal communities. But we actually do have an alternative, because when we are developing our coastlines with concrete, we're replacing amazing habitats like coral reefs, oyster reefs, mangrove beds, and rocky reefs. Do you know what is the main thing for these ecosystems? They are natural coastal protections, the way nature intended. And unfortunately, we are losing these barriers for concrete structures. And concrete in the marine environment is not a surrogate for natural reefs. It has 3 major problems. First, the material composition is very harsh on marine organisms. Second, we're seeing a very smooth surface for concrete structures that interferes with the ability of life to thrive. And finally, the design of these elements is featureless and basically leaves no room for diversity of organisms. Therefore, we're seeing that concrete structures are dominated by invasive and nuisance species. And this is what inspired eConcrete to come and make a change. And we're basically bringing concrete to life with our new technology by tackling each of those three components through principles of biomimicry. Let's start with the material composition. We've developed a new additive to the concrete that is made nearly entirely of byproducts, and it actually replaces only 10% of the cementitious materials in the concrete. That's almost like salt and pepper for the concrete. And that neutralizes the negative effects of concrete on marine life and enables a much richer community to develop. The second level is the surface complexity. So we're using different nature inspiration, including shells of oysters, including polyps from corals, to come up with roughness that allows for marine organisms to attach and actually thrive on the concrete. And finally, three-dimensional designs. We're drawing inspiration from natural habitats like rock pools, or adding holes for different fish that needs a shelter. These three components work in synergy to bring the concrete to life and really enable a healthy ecosystem. And we're doing that without compromising the strength or the operational capacity of the structure. We have several products already performing well over different countries across the globe, including our tide pool armor that won the Biomimicry Design Challenge just a couple of years ago, including our ecological armor blocks that can be used for breakwaters and revetments, pier pile encasements, which we can also do retrofitting of old piers, our ecological mattresses that can help us protect coastlines from erosion and also help prevent erosion from offshore energy facilities like offshore wind. We have different seawall designs, and we keep innovating. This new next generation tide pool is going into construction just next month in San Diego Port. And this is how life adheres to eConcrete. You can see a full cover of oysters and corals and tubeworms that are completely engulfing the concrete, bringing it to life. This has multiple advantages, starting with obviously environmental and biological advantages, like having more biological niches, better ecosystem services, increased water quality, and less invasive species. But we're also seeing structural advantages because of the life that develop on eConcrete. We are seeing a basic crust that increases the strength and durability of the concrete in a process called bioprotection. The beauty is that those same organisms are actually creating a huge carbon sink. So in the process of calcification, those organisms like oysters and corals are actually taking CO2 from the water and making it into calcium carbonate, and therefore are enabling us to offset some of that huge carbon footprint that's associated with concrete. And it's not going to happen once. It's going to happen throughout the entire lifespan of the structure, 30, 50, 100 years, or even more. And this is when I want to talk about circularity. Unfortunately, full circularity in coastal and marine infrastructure that are made of concrete is just not feasible at this stage because of technology limitations. Recycled concrete is just not strong enough for making seawalls that will endure a century. But what if, instead of breaking down the structure, we could actually make it part of nature and have it highly diverse, offering different niches for ecological ecosystems, and therefore making it one with nature. That's our vision. On top of that, we also use some classic circularity components. For example, our admix is made nearly entirely of byproducts, as I mentioned. And our mold system is made of separate materials so that we can break it down when it's finished its service and reuse it. We think that when you work with nature and with biomimetic technologies, you're able to enjoy so many advantages spanning from environment, biology, structure, and even permitting. And this is something that cannot be done without multidisciplinary thinking. And for here, I want to thank our multidisciplinary team in eConcrete that includes biologists, ecologists, concrete technologies, product designers, coastal and marine engineers, marketing and sales, everybody working together towards our goals and towards scaling our impact. We have at the moment 30 installations across 6 seas and 8 countries with different entities from ports to cities. And we want to keep increasing our impact by going into mega infrastructure projects. Like, for example, this amazing Living Breakwaters project that's going to go into construction next year and protect communities in Staten Island. This project includes hundreds of e-concrete products. And actually here, the ecological design also reduced the mitigation penalties of the project, therefore making biomimetic technologies also cost effective. And finally, our impact. It's not easy to measure biological impacts, but we do a lot, and we measure our impact from our studies. And I can tell you that getting double the biodiversity, double the species richness, less invasive species, a stronger carbon sink, and better water quality is what we can gain. And here we can use everybody's support to spread the word, and through the Biomimicry Institute and with the Ray of Hope Prize to bring our win-win technology to every community and every coastline that needs it. Thank you so much.